Hello and welcome back to Chemistry with Kenny. We are carrying on our series looking at the GCSE Physics spec. Now what we're going to look at today is Hooke's law. Now this is a really common, and you've probably done this practical loads of times. It comes up in Key Stage 3 as well as IGCSE. And basically we're looking at things that are stretching. So that could be elastic bands, it could be springs. You can also do this for just pieces of wire and different materials. But most commonly it is springs, so that's what we're going to kind of focus on today. So starting with Hooke's law itself. Now, what we mean when we say Hooke's law is, and this is our definition we need to remember, the extension, so the stretch of an elastic object is directly proportional to the force applied. Okay, so what that means is as you're putting on force to a spring, for example, the amount that it's extending should be directly proportional to the amount of force you are adding to it. Okay, now this only applies only up to the limit of proportionality. Okay, sometimes this is called the elastic limit. So you'll know this from if you've ever played with a spring. You can kind of pull it, let go, it goes back, and you keep doing it. At some point, you put enough force on that spring, you pull it far enough. When you let go, it doesn't go back to its original shape anymore. That means it has gone past this limit of proportionality or gone past this elastic limit. Now, when we're carrying out this experiment, you're going to set up a spring, really simple, with a clamp stand, and you're going to be adding mass onto the end of that spring, adding a force. Okay. Now, something to be really careful about. You are playing with springs as you load those springs, as you put force on. If that force was suddenly disappear, that spring is going to go flying. So I would always recommend wearing goggles in this kind of experiment. It seems a bit silly because it's just a little spring. If that flies off and it hits you in the face, it's going to do some damage. Same as making sure we don't put our feet under the mass, because if that spring does break, if it reaches that elastic limit and it breaks, and those mass come flying down and land on your foot, even if it's only a kilogram, it's going to really hurt because it's going to be falling. Okay, so it's going to pick up a bit of momentum, which we're going to look at in a future video. Now, here on the left, we have our original spring. So here's where there's a few bits that you need to be really careful about for Hooke's law. So we need to measure the original length. Okay, so we can tell that the original length is going to start up here. However, do we take the original length from the bottom here, or do we take it from the bottom of the kind of bit that the mass is going to stick onto? Now, this is up to you in your experiment. However, you need to keep it consistent. And this is called a systematic error. So wherever you measure from, every single time you have to do the same. Okay, you can't be first time measuring this as the length and then next time you measure this as the length. It doesn't work like that. Okay, you need to keep it consistent. Now, just for this, I'm going to go with the one that's on here. So this is our original length. Okay, now original length was here, and now we can see we've added some mass on here. This might be 100 grams. It could be 10 grams, depends on your spring completely. Okay, and we can see that that spring has now moved. Okay, and that spring, now I'm going to take from the same place, the bottom of the spring, and it has now gone to here. This is our extension. Okay, this is the part that we are actually measuring. Okay, this is the part that we want to measure and add in and note down on our table. Okay, we're not measuring the length completely. Well, you are measuring the length completely. However, you're going to take away the original every time. Okay, this is our dependent variable. Okay, now the mass that we added on, this 100 grams or whatever, this is our independent. However, if we think about the definition at the top, let's talk about force. So we actually need to use the W equals mg equation and turn that into a force. Okay, we don't want to use it as mass, we want to use it as a force. We want it to be in newtons. So we're looking at the weight, because obviously that mass is going to have a weight associated with it. So now we've gone kind of through all that. At the bottom here is step-by-step guide to actually completing this investigation. I'm not going to fill this all in now, but you can go ahead and do it. Remember, for this weight, let me change that color. It's a bit hard to see. W equals mg. Okay, this mass needs to be in kg when you do this. Okay, so you can go through, you can have a go at doing this for yourself and see what numbers you come up with. Once you've got those numbers, we are going to be putting it onto a graph. So here we've got force, which is measured in newtons, and we got extension. In this case, I'm actually measuring it in centimeters on my table below. However, most commonly, this is in meters. Okay, so we would convert those as well. Now, here, obviously we've got 0 at the bottom, and this is extension, so it's how much that spring has stretched. You'll get this shape to start with, and this point right here, this is our limit of proportionality that we spoke about earlier, or the elastic limit. After this point, you'll actually see a curve. Okay, now this point at the end of the curve is break. So if you go all the way to that point, you'll actually, the spring will most likely snap. Okay, so we normally, when we're doing this experiment, we want to stop at this point the best that we can. Sometimes people even stop a little bit before it because you don't need to break it. It's just a waste of material. But you'll get this graph here. And what we should see, if this is a Hooke's law or a material that's following Hooke's law, is straight line. Okay, if we see straight line, this follows Hooke's law. Okay, happy days. If it isn't a straight line, it means that that is an object that's not following Hooke's law. Okay, so you will see some graphs that have different shapes to them. Elastic bands are a bit of a funny one. If you have a go and do this with elastic band, you'll see something a little bit different. And if something follows Hooke's law, we can say that it has or is an elastic material. Okay? And things can be elastic materials up until a certain force. Things can be inelastic, which means it doesn't follow Hooke's law up until a certain force. Lots and lots of different things, lots of different materials. So have a play, try different materials, try different things out, and see how you get on. But that is the basics of Hooke's law.